A countersink is a conical hole cut into a manufactured object, or the cutter used to cut such a hole. A common use is to allow the head of a countersunk bolt or screw, when placed in the hole, to sit flush with or below the surface of the surrounding material. A countersink may also be used to remove the burr left from a drilling or tapping operation, thereby improving the finish of the product and removing any hazardous sharp edges. The basic geometry of a countersink inherently can be applied to the plunging applications described above and also to other milling applications. Therefore, countersinks overlap in form, function, and sometimes name with chamfering end mills. Regardless of the name given to the cutter, the surface being generated may be a conical chamfer or a beveled corner for the intersection of two planes. Types. Machining. A countersink may be used in many tools, such as drills, drill presses, milling machines, and lathes. Cross-hole countersink cutter. A Dan Martin style zero flute countersink is a cone-shaped tool with a cutting edge provided by a hole that goes through the side of the cone. The intersection of the hole and cone form the cutting edge on the tool. The cone is not truly symmetrical, as it is essential that the cone retreats away from the cutting edge as the tool rotates, providing clearance. If this does not occur, the cutting edge will lack clearance and rub rather than bite into the material. This clearance is referred to as cutting relief. These tools are best used as deburring tools, where the burr from a previous machining operation needs to be removed for cosmetic and safety reasons. However, they may be used in softer materials to create a countersunk hole for a screw. Fluted countersink cutter. The fluted countersink cutter is used to provide a heavy chamfer in the entrance to a drilled hole. This may be required to allow the correct seating for a countersunk head screwer to provide the lead-in for a second machining operation such as tapping. Countersink cutters are manufactured with 6 common angles, which are 60 degrees, 82 degrees, 90 degrees, 100 degrees, 110 degrees, or 120 degrees, with the two most common of those being 82 degrees and 90 degrees. Countersunk head screws that follow the unified thread standard very often have an 82 degrees angle, and screws that follow the ISO standard very often have a 90 degrees angle. Throughout the aerospace industry, countersunk fasteners typically have an angle of 100 degrees. Back countersink. A back countersink, also known as an inserted countersink, is a two-piece countersink used on tough-to-reach areas. One component is a rod that is inserted into the existing hole in the workpieces. The other component is the cutter, which is attached to the rod, or extends out of it, after it is in position. This is comparable to other types of back machining, such as back spot facing, back boring, back counterboring, back milling, and back deburring. The common theme is accomplishing machining operations on the far side of the workpiece from the spindle face, which obviates a second operation, setup. This reduces setup time and frustration in several ways. Not only does it obviate the flipping over, cleaning, or clamping, etc., but it also can allow effortless high concentricity, parallelism, and squareness with the first setup's datum without the hassle of re-establishing it on another setup. Speeds, feeds, and avoiding chatter. It can often be difficult to avoid chatter when cutting with countersink cutters. As usual in machining, the shorter and more rigid the setup, the better. Better quality fluted countersink cutters sometimes have the flutes at an irregular pitching. This variation in pitching reduces the chance of the cutting edges setting up a harmonic action and leaving an undulated surface. This surface ripple is also dependent on the surface speed of the cutting edges, material type, and applied pressure. Once started, it is hard to remove. Too light a feed tends to increase chatter risk. As in many other machining operations, an appropriate response to the chatter may be to decrease speed and increase feed. On a drill press, the slowest available spindle speed is usually best. With a variable speed handheld powered drill, the trigger is best squeezed lightly to yield a low spindle speed. Good chatter-free results can usually be had by countersinking by hand. The slow speed and sensitive feet tend to prevent chatter. With a 1/4-inch hex shank, the countersink cutter can be held with the screwdriver handle of the indexable bit type. Form countersinking. Form countersinking, also known as dimpling, is a countersink that is formed into sheet metal to increase the strength of a structure as the countersinks of multiple pieces nest together. There are two processes for producing formed countersinks: coin dimpling and modified radius dimpling. Such dimples in fairly thick sheet can even be tapped to yield a threaded hard point on the sheet without the bother and expensive welding a nut to the sheet. This style of construction is often seen in modern household appliance design, because it allows the product to be lower priced, and the quality can still be good as long as the sheet is thick enough.